Now that you've seen how to do elimination, let's go ahead and add it to our foldable. We're going to write elimination on our last tab. And if you remember with the last two, we started with substitution, then we did graphing, and we used the same system of equations. We're going to use that same system of equations so you can see how it works with elimination. Now remember, for elimination, you want to get the coefficients on the x's or on the y's to be the opposite so that we can add the two equations together. In order to do this, I'm going to need to multiply one of the equations by -2. I'm going to go ahead and multiply this top equation by -2 because then when I add the x's together, they will be eliminated. First, I'm going to rewrite the top equation, and then I'm going to multiply both sides of the equation by -2. Here, I'll need to distribute the -2 to both terms, but I'll get the -2x that I need minus 4y equals -40. Now I have the opposite coefficient, so I'll go ahead and just rewrite the second equation. And now I'll add these two equations because all of my like terms are lined up in columns. So when I add -2x plus 2x, I get 0x. -4y plus y, -3y. And -40 plus 19 is -21. This is 0x, and I just put that there so that you can see it. But we actually don't even need to write that if we don't want to. So we're just left with -3y equals -21. To get y by itself, I divide both sides by -3, and I end up with y equals 7. Using this, I'm going to put it back up into one of the two equations and then solve for x. I'm going to choose this first one because this first one has a coefficient of 1 on x, so it's just going to require less work in the end, but you could choose either of those. I'm going to rewrite my first equation. X plus 2y equals 20. And now I'm going to substitute this 7 in for this y and find out what x is. Subtract 14. From both sides of the equation and gotten x equals 6. So don't forget to give your answer in the form of an ordered pair. If you take a look, the elimination way, last week I described it as kind of a neat little trick you can do. And you can see if it's set up correctly, it's a much faster way to come to the answer. Depending on the equation, some equations lend themselves to elimination, especially if the coefficients on x or y are the same coefficient or even better, opposites. If they're already solved, slope-intercept form, oftentimes it's easier to graph them. And if one of the equations has a 1 for its coefficient, substitution might be the easiest. Thank you.